of numerical computing series. In this video I will going to teach you another method of numerical computing, root finding method, which is Newton-Raphson method. In this video I will be using some formulas through which we are going to get the root of the equation. So let's not waste our time, start with our video.
Hello everyone. So let's start with the next method, which is Newton-Raphson method, which is Newton method. So in this we have a formula, which is only one formula, which is xn plus 1 is equals to xn minus f of xn upon f derivative. So in this we have an equation. We will going to have an equation, and we also going to take the derivative of this equation, and because we have to use the f of derivative of f of xn in this video, in this method. So you will going to get to know in the video when I will going to perform this method. So let's start with this method. We will be going to use the same equation which we are using in the previous methods, which is f of x equals to x cube minus x minus 1. So we were going to find the derivative of this equation in the starting of the video, f of x, which is x cube minus x minus 1, and the derivative of f of x, which will be now equals to 3x square minus 1. This is the derivative of the equation. So we have the equation and also the derivative of that equation. So because the equation, we will going to find the f of x over here, and we will going to find the f derivative of x over here. So now let's find there will be a question in your mind, like in previous method we have two values of x in which we were finding, which was x0 and x1, through which we were finding the root of the equation. So don't worry, here we have same method. We were going to find the numbers. If you put 0 in this equation, we are going to get 1 minus 1, and if we put 1, we will going to get same minus 1. If we are going to put 2, we will going to get 5. So the sign is changing over here. We are going to consider these two numbers, 1 and 2. So there will be a question in your mind that how can we put these two numbers in this formula where there is only f of xn or xn. So don't worry, we will going to take the average of these two numbers, average, which is going to give us xn. So average will be 1 plus 2 upon divided by 2, which will be 1.5. so we got the average. This will be our xn, which we are going to put in this formula. So let's put this value in the equation to find it f of x. So f of x will be found through this. We will going to get f of x, which will be going to equation. Firstly we use the calculator. 1.5 minus 1.5 minus 1, it will be 0.875, and f derivative of 1.5, which will be 5.75. so we will going to put these three values into the equation to find the f of xn plus 1, which will be going to x2 it is x0. If it is x0, we will going to find x1. Now for x1, suppose for x1 we will going to perform this method. So xn, which is 1.5 minus 0.875 divided by 5.75. so the answer will be 1.35. so f of, now this is our x1. Now our equation changes to x2 is equals to x1 minus f of x1 derivative of f of x1. So now we are going to have x1 over here, which is 1.35, and f of x1, which will be going to be 0.1007, and f of x derivative of x1, which will be going to be 4.45. So now put this into the formula for x2. Now we will going to do working for x2. Now x2 is equals to f of x1, which is 1.35 minus 0.1007 upon 4.45. Now we will going to get our third value, which is 1.3727. This is our x3. So and so on, we will going to perform these equations again, like x3 is now our is 1.32527, sorry, and f of x3 is 0.011. like you can see, we are getting closer towards 0. And f of x3, which is derivative of f of x3, which is 4.29. So again, we will going to put these three values into the formula and we will going to find x4, and so on. We will going to continue doing this equation until and unless we get to our root or desired value. Thanks for watching. This was our third method, which was performed by me. So hope you got to learn something new from this video. Thanks for watching. Hope you like this video.
In this coding, we have defined a function f of x, which has carried our equation, which we have just performed in previously in our video. And then we have g of x, which is the derivative of this equation, which we have entered in f of x. Then we have another function which is which is named as Newton-Raphson function, and it has attribute x0, e, which is toll, and then we have number of iteration, which is denoted by n. Then we will print this Newton-Raphson method implementation. This line, it tells us that the method is started from here. Then we have initialized another variable which is named as step, and it is initialized by 1. It will count the number of steps or number of iteration performed in this function. Then we have initialized a flag over here. Then we have initialized a condition variable also over here, which is true. And then we have while loop condition. If the condition is true, it will going to run, else it will going to break over here. Then after entering the while loop, we have another condition which is if g of x not double equals to 0, then it will going to print this line which says that divided by 0 error. Then it will break the loop over here. Then if it is not valid, then it will going to proceed and go down. Then we have formula which of x1, which says x0 minus f of x0 divided by g of x0. And then we have another print statement which is going to print the number of iteration performed over here in this line. Then we have then we will going to enter the x0 will be replaced by x1. Then after that every step will be incremented by 1. Then we have another condition which says it should be, if step is greater than n, then flag will get 0 and loop will break, while loop will break. And then we have another way. Then we will change the condition statement by condition by equals to absolute f of x1 should be greater. If it is greater than e, it will going to tell us whether it is false or true, and it will going to break or continue the loop. Then we have another condition which is flag double equals to 1. If flags double equals to 1, it will going to print this line, else it will going to print this line. Then after this, we have our inputs over here. First of all, we have the input of x0. Then we have input of e, which is the toll. Then we have an input of n, which is the number of iteration. Then we were going to convert these three inputs into float, and the first two into float, then number of iteration into integer. Then we have called our function over here. Now let's run this function over here and see the approximate guess. We have found that this was 1.5. It was 1.5. Now enter this.
it, and we are going to set the tool at 0.001 something. Now let's maximum step should be given 100, at least 100. So the approximate root is 1.32, and number of iteration performed is 3, and this is the detail of number of iteration performed. So this was it. This was the coding of Newton-Raphson method.
So this was it. This was a video on Newton-Raphson method. Hope you learned something new from this video. Got to learn more formulas to find the root of the equation. So hope you are enjoying our numerical computing series. So follow us and subscribe us, and follow us in the journey of numerical computing.